Let's do a small experiment. Would you rather drink this water or this water? Well, of course you would choose the water on the left. Unfortunately, some people in other parts of the world have no choice at all. Did you know that small floating particles in drinking water can make you sick? Imagine we have a super powerful microscope and we can zoom into the water. Zoom! What will we find? What are these small floating particles and how do they float? These particles are of two types: inorganic, like clay, silt, and mineral oxides, and organic, such as algae, protozoa, and bacteria. The bacteria, once ingested by humans, can sometimes be fatal. All of these small particles are able to float because they are not heavy enough to settle to the bottom by gravity. Suspended particles that are too light and small to settle are called colloids. When looked at together, these colloids cause a state of cloudiness or haziness known as turbidity. The more cloudy a fluid looks, the more turbid it is. Here we see 4 beakers of water with increasing levels of turbidity from left to right. There is a relation between turbidity and the risk of getting a disease. Science shows that the more turbid the drinking water is, the higher the risk of getting sick is. Now, why is this? This is because toxic compounds can adsorb, that is, stick to, the surface of the suspended colloids. The more colloids there are, the more toxic the water can become. These toxic materials and bacteria can cause cholera, salmonellosis, hepatitis A, dysentery, and E. coli infection. These illnesses affect and kill millions of people a year and are especially dangerous to children whose weak immune systems cannot provide an adequate defense. Fortunately, we can do something about this. One of the very practical ways to clean this turbid water is called flocculation. Flocculation is the process in which colloids aggregate or come together to form larger particles called flocks by the addition of a chemical called a flocculant. Typical flocculants include alum and ferrix because they work well with high turbidity fluid mixtures. Now, let's demonstrate how flocculation works. First, we'll need to go out and collect some muddy water from the Charles River. Here are 2 beakers filled with the same amount of muddy Charles River water. On the left is our control, which will remain untouched, and on the right, we'll add 3 milliliters of prepared flocculant solution. Then we'll stir for 2 minutes and wait. Wow! What just happened? The colloids in the turbid water on the left may never settle, whereas with the addition of just a little bit of flocculant, the water on the right became clear. In order to make this water potable, it will require skimming and filtration and maybe some additional treatment. If you're wondering what's going on, let's explain how this flocculant business works. Almost all colloids have negatively charged surfaces. This means that positive ions, or charged particles in water, will attract to the colloid surface, forming a first layer. Recall how like poles of a magnet will repel, while opposite poles will attract. The same occurs with colloids in water. A diffuse layer, made up of a mix of positive and negative ions, will then surround the first, forming what is called a double layer. This double layer provides a repulsive force that prevents 2 colloids from sticking to each other. Once the flocculant is added, it adheres to the surfaces of the particles, compressing the double layer and allowing the colloids to stick to each other and form flocks. These flocks are now heavy enough to settle to the bottom by gravity. Given how effective flocculation is, many countries around the world use this method for cleaning their water supplies. Did you know that Singapore, for instance, produces drinking water from sewer water using a number of methods including flocculation? As the global population increases and fresh water resources become more and more scarce, flocculation is one tool that can supply clean, healthy, and tasty drinking water worldwide.